For this lesson, we're going to learn how to use a graphing calculator. So before we begin, you need to make sure that you have one of the yellow graphing calculators. Your essential question is, how do I enter equations to graph in the graphing calculator? So to input equations into the graphing calculator, these are the basic steps that you're going to follow. First, you're going to go to the y equals screen. Now, I'm going to pull up my graphing calculator so you can see here. The y equals button is right here. So if you press that, this is what is referred to as the y equals screen. Then you'll just simply type in your equation. Anytime you put in fractions, you need to put them in parentheses so it doesn't mess up the order of the equation or like the way that it's operated. So for example, if I wanted to put in 1/2, I would put in parentheses and then I would do 1 divided by 2, like this. If something needs to stay, let me move this over here. If something needs to stay inside, like some symbols, or inside under a square root, then you have to use parentheses to tell the calculator where the symbols are supposed to start and stop. So for instance, if I wanted to do like x plus 1 and I wanted the entire x plus 1 to be under the parentheses, under the square root, rather, then I would go to second square root, which is right here. And then I would type in x minus 3, and then I would close my parentheses to show that x minus 3 is all underneath the square root sign. And then if there was like a plus 2 outside, then I could put plus 2, and that would show that that would be outside the parentheses. Something else you can do is, if you have absolute value, you can go to that function which is under math, and then if we arrow over to the number screen, the very first one is absolute value, and so you need to hit enter. And then let's say that I wanted the absolute value of x plus 5, and so I would type in x plus 5, and then I would close my parentheses to show that that's where the absolute value symbols stop. And then I would put in like minus 3 or minus 1 or whatever is outside the symbols. So those are just some basic things. Before you're starting, this is very important, you need to press zoom, then 6, so that your calculator is in the standard viewing window. So we're going to go to zoom, which is right here at the top, and then 6, see how it says Z standard, 6, and this makes your graph go to the standard viewing window, which is from -10 to +10 on the X and the Y axis. So that's what that means. All right. Let's try some examples. Now I've included the steps for each equation on here so that you can write these down in your notes if you want to. If you feel like this is something you already know, you don't have to write it down, but it will be helpful if you forget how to do this. So we're going to enter the following equations into the graphing calculator, and we're going to do each of them separately, and then we're going to tell whether the graph is a function, and we're going to find the domain. And we've already done those two things, so this should be a review. So first, we're going to type in the equation y equals 2x plus 4 and then graph it. So these are the steps to do that if you'd like to write them down. Okay, but I'm going to show you with my graphing calculator. And please follow along with me so that you know exactly what you're doing and you can make sure that you're doing it right. So if I type in the equation y equals 2x plus 4. I'm going to go to the y equals screen and type in 2x plus 4. And then I'm going to hit enter, and then I'm going to hit graph up here at the top. And it makes the graph of a line. Hooray! Then I could check, and you guys on your worksheet, you'll sketch a picture of this graph. It doesn't have to be exact, it's just a sketch. Then you're going to perform the vertical line test to check to see if the graph is a function. And if I were to take my pen and draw vertical lines through this, it would only touch one point on the graph. So then that would be considered a function. So then we decided that the graph is a function. And so then we need to see the domain. Well, we can see that the graph, if I travel along the x-axis, the graph comes from negative infinity, because this goes on forever down here. So if I'm moving along, it's constantly coming from negative infinity, and then it goes up and it goes across and across and across towards positive infinity. So the domain would be from negative infinity to positive infinity. And to write that in interval notation, you would put it in parentheses, because we can't physically count to negative infinity or positive infinity. So since you can't see that as a point on the graph, you would put those in parentheses. All right, let's try another one. So let's try the graph of f of x equals x squared plus 4x minus 3. So we're going to follow the same steps. We're going to press y equals. Then you want to clear out the previous equation. So you're going to press clear to get a blank slate. Then you're going to enter the equation as you see it. Now, some of you guys might not know where the x squared button is, so I'll show you that. Then you press enter and graph it. So if we pull up our graphing calculator, we're going to go to the y equals screen and clear out our previous equation. And then we're going to enter in x. And then the squared button is right here, x squared. And then plus 4x minus 3. And then hit enter and graph. And you'll notice that this graph looks much different. It's a parabola. And so you could sketch a picture of this onto your worksheet if you were doing that. And then we are going to tell if the graph is a function. So we would perform the vertical line test. So if I was to draw vertical lines through this graph, it would only touch the graph at one point each time. So therefore it would be a function. And then we're going to state the domain. So if I'm moving across the x-axis from side to side, this part of the parabola would continue on forever and ever and ever, and so would this side. And so it would gradually keep going over and over and over and over and over. So it would go from negative infinity to positive infinity as well. And so we would write it the same way. Let's take a look at some more complex examples. So for x cubed equals negative x plus 1, we're going to basically do the same thing. We're going to go to the y equals screen and clear out the previous equation. We're going to enter the equation as we see it. And some of you might not be familiar with how to type in exponents higher than a 2. So anything higher than a 2, you're going to use this caret key over here. So that raises it to whatever power you want. And then we're going to press enter and graph it. So we'll go to the y equals screen again, clear out our function. Okay, then we're going to type in x, and then this caret key over here raises it to the third power. So that is x cubed. And then minus x, and then plus 1. Then we're going to hit enter and graph. And this one kind of looks like a snake, okay? It's forever going down on this side, and even though it's very gradual, it would keep continuing over and over and over and over. And so with this side going up, it would keep continuing up very slowly over to the right. So to do the vertical line test, we would draw vertical lines through these, and it would be a function because it would only cross through one point each time. The domain would be from negative infinity to positive infinity, because as we're going across the x-axis, we would be able to see the graph, if it was very large, that it would go through any point from negative infinity to positive infinity. All right, the next example that we have is an absolute value function. So we have f of x equals the absolute value of x minus 2 plus 3. So for absolute value, after you go into the y equals screen and clear out the previous equation, to get to your absolute value symbols, you're going to press the math button, which is right here underneath that alpha button on your calculator. And then you have to arrow over, because the screen will pop up like this. You have to arrow over to the number screen. And then the very first option is ABS, which is the absolute value. Then you'll press enter on that. And then you'll type in the x minus 2. And because the x minus 2 is all that's in the symbol, we would close our parentheses after that to show that that's where the symbols end. And then you would type in the plus 3 and then press enter and graph. So if we go to our y equals screen and clear out what was already there, to get absolute value, we're going to go to math, which is this button right here. And then we're going to arrow over to the number screen. So press the right arrow, and then it's already on absolute value. So you just hit enter. And then we type in x minus 2. Close your parentheses to show that that's where the symbols end. And then plus 3. Then we'll enter and graph. And this is what we see. Absolute values make a V shape. Pretty cool. So if we were to test to see if this was a function using the vertical line test, when we draw vertical lines through the graph, we would see that it only touches one point each time. So this one is again a function. And then if we state the domain, we can see that this side goes on and on and on, and so does this side. And so the domain again would be from negative infinity to positive infinity. All right, one last example. Okay, this time we have a square root function. So we're going to look at y equals the square root of x minus 5. So this time we're going to go to the y equals screen and clear out our previous equation. To get to the square root button, you have to press second and then the x squared button, because if you can see in yellow right here, the x squared is above, or the square root is above the x squared button. So you press second square root and then type in x minus 5, and then we want to close our parentheses to show that the x minus 5 is all underneath the square root sign. And then we'll press enter and graph it. So we'll go to our y equals screen, press clear, then we'll type in second, and then up here is square root, and then x minus 5, and then we'll close our parentheses to show that this whole thing is under the square root symbol, and press enter and graph. And you'll notice that this one is kind of like half of a parabola on its side, and it starts at 1, 2, 3, 4, 5. So it starts at positive 5. So when we do our vertical line test, this one, if we draw our lines, it would be a function. But our domain is going to be slightly different this time. If I'm going across my x-axis, my graph doesn't start until positive 5. So it would start at x equals 5, and since that point is actually on my graph, then I'm going to put that in brackets instead, because I can actually see the 5 on the graph. And then my graph goes on towards positive infinity. So that part would be in parentheses. So the graph would be a function, and you would write your domain like this, from positive 5 and to infinity. All right, make sure to go back and answer the essential question and write your summary.